So what do we do if our hyperbolic function has an x term in the numerator, the top of the fraction? It is still a hyperbolic function. Let me show you in Desmos. Here it is, y equals 3x minus 1 over x plus 1. Has that hyperbolic shape. It's symmetrical along the diagonal. The vertical asymptote is as kind of what you'd expect. X plus 1 equals 0. Solve for that. X equals minus 1. Vertical asymptote. Y is equal to 3. There it is there. We can see it looks like it's behaving nicely for an asymptote. It might not be completely clear here why it's 3, but that's okay. It definitely has one. Well, it turns out that we can actually change what this graph looks like into a form which does exactly look like something that we're used to in our transformations of the hyperbolic graph. So here I've got y equals 3 minus 4 over x plus 1. And if I turn it on, you'll see it perfectly covers the red graph. There we go. I've turned it off and turned it on. So if the purple graph here is exactly the same as the red graph, then they are effectively the same function, because whatever I put in for x outputs to exactly the same values for y in the red graph as it does for the purple graph. So these are identical functions. So with a bit of algebraic manipulation, we can change this the form of this function into the form of this function, and this is something that we're used to. If we look at this, we can go, this is the hyperbolic function with a translation to the left, with a dilation in the direction of the y-axis by 4, with a reflection, and with a translation of 3 units upways. I didn't list those in the right order there, but I'm just saying each part here is just like the transformations we've been looking at in class. Okay, so how do we go about doing it? Here it is here. We're going to use a little trick, and the trick kind of, to me, feels a little bit like completing the square. You're sort of getting it into a shape that you know that you're looking for, and going from there. Let me start by saying what you can't do. What you can't do is you can't go, well, I'll just cancel out the x's. It doesn't make sense. We're going to have 3 minus 1 on the top, which is 2 over 1. It's not the graph y equals 2. As a general principle, I find students still sort of struggle with this concept a bit. You cannot cancel numbers out or variables across an addition or subtraction sign. You can't. If it's the product, you can. If there's an addition or subtraction involved, you can't. You can't just cancel down the x there. But what we can do is we can cancel out an entire expression like x plus 1. So what we're going to do is we are going to sort of artificially build an x plus 1 term into our numerator. So watch what I do. I'll have to spell it out a little bit. So I'll go to the right color. So I know that I want to be left with an x plus 1 on the top. Why? It'll be clear as I go along. In order to get the x plus 1 out of the top, I need to sort of take 3 out as a common factor. So I'm going to put a 3 here, and that gives me an expression of 3 multiplied by x plus 1. Okay, if I expanded this, I would have 3 times x is 3x. I'll do it in another color so it's just verbalized there. So if I expanded that, that would be 3 times x is 3x, and 3 times 1 is 3. So if I expanded it, I would have 3x plus 3. But I need a minus 1 for these expressions to be equivalent. So to get a minus 1, I'm going to have to subtract 4. Okay, so that keeps this expression and this expression exactly the same. Okay, I've just reordered what it looks like. The question you might be asking, and it's a fair question, is why on earth would I do that in the first place? Well, now that I've got my fraction split up, now that I've got my numerator into 2 sections like this, I can use my fraction knowledge to split this fraction up. And so the next line becomes y is equal to 3 outside of x plus 1 all over x plus 1 minus 4 all over x plus 1. Okay, it's just the same as saying that 5 over 7 is equal to 3 plus 2 over 7, which is equal to 3 sevenths plus 2 sevenths. As always, if it works in Numberland, it works with algebra as well, because algebra is just numbers anyway. Okay, so now that we've split it up, we can do a cancel down, because I am cancelling down an entire expression. We've got 3 lots of the expression on top. We've got a lot down the bottom, so they can cancel out. That leaves me with 3. Sorry, change colours again. That leaves me with 3 left over here on the left, minus 4 outside of x plus 1. Or if you want to, I'd leave it like that, but if you really wanted to, you could make it negative 4 over x plus 1 plus 3, if you wanted to have it in a kind of the format that we're used to. So there you go. There's the expression. And again, just to confirm, 3 minus 4 over x plus 1. And if I go back to Desmos, we have 3 minus 4 over x plus 1. And it is identical to the expression